Salt bridge and its function. The two main functions of the salt bridge are as follows. It allows the movement of ions from one solution to the other without mixing of the two solutions. Thus, whereas electrons flow in the outer circuit in the wire, the inner circuit is completed by the flow of ions from one solution to the other, and hence the current flows. Second, it helps to maintain the electrical neutrality of the solution in the two half cells due to flow of ions. Example, SO4, two negative ions may shift and combine with the Zn2 plus ions in the first half cell. If the salt bridge is not employed, the flow of electric current will not occur, as explained below. The moment of the two rods are connected by a copper wire. The flow of electrons from zinc to copper rod occurs for a short while. As a result of this transference of electrons, a net positive charge is developed near the zinc rod. On the other hand, Cu2 plus ions accept the electrons released by zinc rod and get deposited on the copper rod as Cu. This leads to an excess of SO4 negative ions in the solution, and hence a net negative charge is developed around copper rod. The positive charge accumulated around zinc rod will prevent electrons to flow from zinc rod towards copper rod, while the negative charge developed around copper rod will not allow Cu2 plus ions to accept the electrons released by zinc rod. Consequently, the reaction will stop and no current will flow. The use of salt bridge, on the other hand, avoids the situation as explained below. As Zn2 plus ions are produced near the zinc rod, an equal number of SO4 negative ions will move from the salt bridge towards zinc rod, thereby neutralizing the positive charge around zinc rod. Similarly, K plus ion will move from the salt bridge towards the copper rod, thereby neutralizing the negative charge due to an excess of SO4 negative ions around copper rod. As a result, the solution in the two beakers remain electrically neutral and thus allow the electric current to flow. Why does the electrochemical cell stop working after some time? The electrode potential of any electrode depends upon the concentration of ions. With time, as the cell operates, the concentration of the metal ion, Zn2 plus ion, in the anodic compartment increases, and hence electrode potential of anode also increases. At the same time, the concentration of metal ions, C2 plus ions, decreases in the cathodic compartment, and hence electrode potential of the cathode also decreases. Ultimately, the electrode potential of the two electrodes become equal. At this stage, the cell stops working, since E cell, which is equal to the difference of the electrode potential of the cathode and anode, becomes 0. What would happen if no salt bridge were used in the electrochemical cell? Example, Zn, copper cell. The positive ions Zn2 plus formed by loss of electron will accumulate around zinc electrode, and negative ions SO4 negative left after production of Cu2 plus ions will accumulate around copper electrode. First, the solution will develop charges and the current stops flowing. Further, since the inner circuit is not complete, therefore the current stops flowing. Thank you.